Tampering is acting to change the design of work without knowledge of the system within which it resides. It is change on the hoof with reliance upon limited or no data, carried out by those who favour action over study and opinion over knowledge. It is a bad way to go about changing a system in order to improve its performance. Tampering is very common. It is how change is generally done within any command and control system. Managers are told it is their job to somehow innately know the answers to problems that arise and to know how to fix them. Consequently, it's assumed that they don't need to study their systems. Moreover, a manager seeking to study their system risks exposing a perceived lack of knowledge or credibility and charges of procrastination. So, command and control systems create managers whose instinct is to act and hope rather than to learn and improve. We recently saw this in a high street retailer whose system we studied. They had a problem called queues. Too many people were waiting too long to be served at peak times. Customers weren't too thrilled with this, with many of them opting to go elsewhere. The branch manager was told to get the queues down, and fast. The system's leadership wanted action, and so the manager was compelled to act rather than to study. The solution offered by the leaders was a self-service ticket machine, where customers selected what sort of service they wanted and took a corresponding ticket. The manager allocated certain counters to certain demand types and would call them up by their ticket number. Customers were essentially sorted and batched. This introduced errors, as people took the wrong tickets or missed their turn when called. As the mass of waiting people grew, the manager would tamper further with the counter allocations to try to retrieve the situation, but instead confused customers and staff alike, and the whole thing ended up in chaos. So why does tampering make things worse? Rather than study the causes of variation, the manager acted on instinct and tampered with parts of the system that had no bearing on the reasons for the queues. The queues were nothing to do with who went to what counter. Moreover, by adding further variables in, he increased error, variation, and made queues longer as a result. Deming illustrated the nature of tampering with his funnel experiment. He created 4 identical systems whose purpose was to land a marble onto a target by passing it through a funnel. By holding the funnel and releasing the marble, it would land somewhere near the target. The first system simply repeats this a number of times. Each drop aims at the target. This produces a number of hits centred around the target and visibly demonstrates the variation within this system. Unlike the first system, the second system responds to the previous result. If the first marble lands 2 inches above the target, the next drop would be aimed 2 inches below the target. If the following drop landed 3 inches to the left of the last aim point, the subsequent drop would be aimed 3 inches to the right of the last aim point. So for Rule 2, we are always responding to the previous result relative to where we were aiming. This produces a similar pattern to the first system, but spread over a wider area. Performance has got worse because we introduced another variable, in this case where we aim the marble. This illustrates the effect of treating the difference between 2 consecutive observations as due to something other than a natural variation within the system and tampering with the aim as a result. Examples of this Rule 2 behaviour include changing practice after a complaint from a single customer and rewarding or punishing a staff member today based on a comparison with yesterday's performance. The third system has the same setup but responds differently by adjusting the previous drop relative to the main target rather than where the funnel was previously aimed, as in Rule 2. Rule 3 shows an even wider variation. It essentially swings results ever wider of 2 sides of the target. This shows a form of overcompensating behaviour where error is compounded. An example of such Rule 3 behaviour is witnessed in agriculture, when a drought causes a price rise, which in turn leads to an increase in supply the following year. This in turn results in a surplus and a subsequent price fall. Farmers respond by planting less, resulting in a shortage. And so it continues. Other examples include borrowing to pay off a debt and the effect of drugs crackdowns on supply and price. The fourth system is the most unstable of all. It simply aims the funnel at the point where the previous marble landed. This results in a random walk off the edge of the page that has the target in the centre. This demonstrates the consequences of blindly copying what has been done before. An obvious example of this is benchmarking, which is essentially copying without knowledge. Other examples include using the most recent incumbent to train the next, or using the previous cut of timber to measure the next one. The result is performance that rapidly moves from the intended or hoped for results. Demi's experiment was designed to demonstrate what happens when you tamper with a system. In the funnel experiment, the causes of variation include the hardness of the landing surface, the height of the funnel, and the density of the marble. If action is taken on these three aspects of the system, variation will decrease and performance will improve. If we revisit our queuing example, there was huge variation from no queue when it was quiet to long queues when it was busy. If the manager had studied why a queue was developing, he'd have learned three things: that it was predictable, this happens at this time and to this extent every day; that there was insufficient capacity to deal with the demand, not enough people serving; and that there was insufficient capability to deal with demand. Not every customer got served by someone who knew how to serve them. At no point during his initial attempts to change the system were demand, capacity or capability understood as the causes of variation. When he understood this, having studied his system, his changes resulted in an improvement from predictably large queues to virtually no queues by getting the right amount of people to serve, ensuring they could deal with the demand that came in, and that this was done at busy times. The role of managers is to act on the system having understood it, not to tamper with it and hope for the best.